All right, good morning and happy Tuesday. I'm planning on doing LeetCode contest from last Saturday. Let me share my screen here. So I didn't do either one. Usually I do the biweekly contest. But this last Saturday I forgot, so I'll plan on doing this one. Biweekly contest 92. So here we go. All right, time to shine. And these guys up. Okay, minimum cuts to divide it. Alrighty. Okay, we need 4. So it's 2 cuts. 3 is 3 cuts. It's a valid cut. Invalid. Okay. Okay, has to go through the center. Okay, so if it's an even number, you just divide it by 2. If it's odd number, then we need those odds. Let's see. There might be some corner cases, but if n is even, right? So if n modulus 2, return n divided by 2. Otherwise, we'll return n. So it looked like, at least from the example test cases. All right, 2 and 3. Oh, 1, it should be 0. Oh, okay. If n equals 1, return 0. Okay, so that was a little bit of a corner case, but not too shabby. Let's just post this real quick. It's kind of silly, but whatever. A few solutions. Okay. We can just rewrite this real quick. Lambda 0 if n equals 1, else n divided by 2 if not n modulus 2, so if it's even, otherwise n. That looks good. Okay. There are 3 use cases. Oops, 3 use cases. I guess two primary use cases and 1 corner case to consider. 1, if n is even, then we need n divided by 2 cuts. If n is odd, then we need n cuts. The corner case for number 2 occurs when n equals 1, for which we need 0 cuts. All right, there we go. Push this guy up. Kotlin, JavaScript, oops, Python 3, Rust, C++, oops. Okay, there's Python 3. Turn n equals 1, 0, otherwise not n modulus 2. If it's even, then turn n divided by 2, otherwise we'll turn n. Looks good. All right, just stick this on one line. Making linters light up like it's Dwally. Okay. N is equal to 1, return 0, otherwise n equals 2. If it's even, then return n divided by 2, otherwise return n. Looks good. Okie dokie. Kotlin. Oops. If n equals 1, return 0. Else if n modulus 2 is equal to 0, return n divided by 2. Otherwise, return n. Looks good. All right, that's cool. Rust, save the best for last. All right. If n equals 1, return 0. Else if n modulus 2 is equal to 0, we'll return n divided by 2. Otherwise, return n. Looks good. Okay, it's cool. Let's move on. Actually, let's make this look a little bit nicer. Case 1. Oops. Case 2. That looks good. This got me a bug. Note. Okie dokie. Looks good, looks good. And we have 1 hour, 23 minutes remaining for Q2. Oops, 1 hour, 23 minutes. 1 hour, 23 minutes in the contest. Okay, we need to capture the number of ones and zeros per row and column. And then use this, the ones minus the zeros. Two ones in that row. One. Strange that it's 0. I thought that would be 1. This is 0, 0. There's 2 ones here. Oh, the 0. Wait, hold on. Zeros in column 1. Okay, so there's 2 ones in that row. 1, 1 in that column. 1, 0 in this row. And then 2, 0. Oh, the zeros counted twice. Okay, since the zeros counted twice, that's why we had 3 zeros and 3 ones. Okay, so we should be able to use a map, right? So game plan is to use a map. Let's count this thing, 10:29 a.m. How many minutes? Whatever. Can't keep track of this. I don't think it'll take too long. Just use 2 maps, right? Use a map for 0. I guess the zeros and the ones we can count per row. So +1 for every 1 and -1 for every 0. +1, -1. Yeah, I think that works. +1 for ones, -1 for zeros per row and column. Right, that's the game plan. Here's my array. Row equals counter. Oops. A row column equals counter. Counter for my do m n equals length of a sub 0, m, or j in range in row sub I plus equals +1 if a sub I sub j, else -1, column sub j plus equals 1 if a sub I sub j, else -1. So it's +1 for ones, -1 for zeros. And then we can formulate the response, right? So return sub row sub I sub column plus column sub j, or j in range in for I in range m. I think that works. Let's see what happens. Uh-oh. Expected an integer. Really? 0, 0, negative. Oh, it should be per. Like that. Okay, 0, 0, 4, 0, 0, 4, -2, -2, 2. Looks right. 5, 5, 5, 5, 5, 5, 5. Okay, yep. Big money, no whammies. Yay. Okay. That took 10:32, 3 minutes. Nothing too fancy. Right, 2 maps. A few solutions. Use 2 maps as counters. Counters for ones and zeros is +1 for each one and -1 for each zero. All right, Kotlin. JavaScript, Python 3, Rust, C++. Okay. Python 3. Write this in C++ here real quick. That will be our counter. Rows, column. Oops. Uh-oh. There we go. M in a tuple. Oops, and just make a pair. Unit size, set 0. Size for auto I 0 to n-1 inclusive. Okay. All right, row sub I plus equals a sub I sub j question mark. If it's 1, then it's 1, otherwise it's -1. Column sub j plus equals a sub I sub j. There's -1 for zeros, and then we'll return the matrix created by each ij row sum. How do we want to do this? put a back inserter to the answer. That should probably work, right? For each row, we'll create the corresponding transform back inserter for each row into the answer. Make it a mutable lambda so we can keep track of the ith row, jth column of A. Ith row, jth column. So actually, we should be able to yeah, this is probably okay. Turn t at the end, turn the answer. T equals row sub, this was I initially, and then t plus equals columns of j for all those j's. Okay, and I think we can accumulate that, right? Accumulate all the j's. Uh-oh, back inserter. Oh, oops, hold on, it's first. Okay, so V, I need a VI. Result. Initially, ith column, jth row. Okay. Result pushback row sub I plus columns of j. Oh, no way. What's going on here? Plus I. Oops. Okay, hold on. Oh, that's not right. I threw in the jth column. What am I not doing right here? Rows of I plus columns of j. Huh. Quite adding up enough. What am I doing wrong here? Oh, I don't need A, right? Wait, in columns, I suppose, and M rows. In columns, rows of, this was I. Result sub j plus equals columns of j. Right, the ith row in the jth column. in something doesn't look right here though. Something's off. It's not quite right. It's adding too many row column. It's easier to write here for each of these guys. I thought I wrote that the same there. Huh. Not quite. What am I missing? Each ith row is part of the result in the jth column. Huh. Hmm. The heck? Row sub I is 0. Column sub 0. Let's just print this out and see what's going on. Maybe my count's off. Yeah, it should be -1 and 1. That's right. 3 and 2. If you add them up, what the heck? Transform each row in values of that row. Jth column of that row. The heck? Result and stream iterator. Push the output. Okay. I throw and print it out. Shouldn't be 0 though. The row should be 1, right? +1. Zero. The 0th row is 1. So why is this not coming up as 1? What the heck? Row in. Oh, it's a different row. Oops. Okay. Okay. That'll do it. All right, there we go. Wait, no, that's not right. Is that right? 5, 5, no. Should be 5, 5, 5. Something's not quite right for that last computation. Okay, I'm trying to get too fancy, obviously, with this working functionally. This is probably just way easier, right? So let's just do this. use C++ the way it's supposed to be used. The results will be pushed onto the answer, placed back. To use the R value move semantics. The results per row. Res.push back rows of I plus columns of J. I keep it super simple, nothing too fancy, and that was way easier, right? Okay, note to self, right? Note to self, right? C++ is good at procedural programming and kind of sucks at functional programming. Yeah, whatever, right? That works. Nothing too fancy. A hell of a time debugging it in a functional way, but it works fine. In a procedural way, the way that that language is supposed to be used. So, right. Good to use things how they're supposed to be used as intended, right? Too fancy. Okay. Then for I equals 0, I is less than n, versus I, j equals 0, j is less than n, less j. Let's see, use row and column as new maps. Okay, and then row sub I plus equals a sub I sub j. If it's 1, then it's 1, otherwise it's -1. Column sub j, same thing, right? +1 for ones, -1 for zeros. Alrighty, and then we'll return, oops, turn each ith row, map each ith row to each column j, so oops, rows of I plus columns of j, something like that. Uh-oh, not a number. Oops, oh. Okay, let's just set these to, well, yeah, instead of using a map, let's just use 2 arrays then, right? Let row equals array, so M filled with zeros, and column array of n filled with zeros. Add those up. No way, really? Ith and jth. Oh, hold on. The sum of this thing. Map each jth row. No, it's each ij cell. Oh, dot keys, right? Keys is what I want. 0 to n-1 inclusive, 0 to n-1 inclusive. There we go. That's cool. Alrighty, yep, nothing too fancy. Okay, Kotlin. Right. M and n equals a pair, a dot size, a sub 0 size, row and column. And var row equals int array, so m. Column is int array, so n. In 0 until m, or j in 0 until n. Row sub I is equals if a sub I sub j equals 1, otherwise -1. Same thing for the row j, or column j. row I, column j. All right, return int array m it dot map each I to int array so it map j to a rows of I plus columns of j. Ready? Something like that. Uh-oh. Listless array. Okay, so it's an int array. To int array. To array. Oops. Array of int arrays. Uh-oh. To typed array. Oh. Big money, no whammies. Looks good. It's cool. Okay, and then rest. Save the best for last. Okay, shorten these up a little bit. Alrighty, so let m and n equal a dot length, a sub 0 dot length, or I in 0 until m non-inclusive, or j in 0 until n non-inclusive. At mutable row, mutable column, equal vector filled with zeros of size m. Oops, and a vector filled with zeros of size n. If a sub I, let's see, so row sub I plus equals if a sub ij 1, otherwise -1. Same thing for the jth column. Okay, and then return 0 dot m dot map, or I see like header map ith value into 0 dot n header dot map jth value sub I, oops, row sub I plus column sub j. Something like that. Expected I32 found bool equals 1. Oops. Equals 1. Iter range. Oh, I wonder if we can just map these. I'm not sure exactly if this will work or not. Oh, we collect it into, okay, dot collect to vector of integers. And collect it into a vector of integers. Looks good. All right, it's cool. Okay, use two maps, row and column. I guess, yeah. I guess count +1 for each one and -1 for each 0 in row and column. Then return the accumulated height. Row and jth column per j cell. Of the input array, something like that, right? Count +1 for each one and -1 for each 0 in row and column. I guess each row and column. To accumulate count +1 for each one. Yes, one. Right, count +1 for each one and -1 for each 0 per row and column to accumulate yeah, that looks good, right? Nothing too fancy. Count +1 for each one and -1 for each 0 per row and column to accumulate each ith row and jth column per ij cell of the input array A. Input matrix, maybe. Yeah, not really algorithmically complex, but it was a lot of typing. Good practice. Okay, 52 minutes left. 2 minutes remaining in the contest. Okay. Okay, when do we want to close the shop? Ith character is Y. It means that customers come at the ith hour. Otherwise, no customers come at the ith hour. And then there is a penalty for 0 to n inclusive. J equals 0 to n inclusive. Okay, if you close the shop at the 0th hour, what does that mean? There's a penalty. The shop is open and no customers come. The shop is closed and customers come. So if it's closed, then it's +1 for each Y. Open, closed. If it close here, then it's +1 for that guy. 0, 1, 2, 3, and 4 is an imaginary thing. Okay, if we return n, then it's all the y or no's, basically. earliest time we can. Okay, so N and Y have competing interests. You want to keep the shop open for Ys and then close it before we get to the Ns. So when the Ns and the Ys meet up, right? So count, I do some pre-processing. Count Ys from, left to right. Count Ns from right to left. And then we want to return as soon as return ninth position where Y is less than or equal to N. The ongoing, right? Ongoing sum of Y is less than or equal to N. I think that looks right. This is a string. The length of the string. 1 a.m. Minutes for implementation. Python 3. Okay. There's N. And then from left to right, and from right to left, 0 times plus 1, 0 times n plus 1, so for I in range n plus 1. Actually, no, just range n, right? So L sub I equals sub I minus 1 if I minus 1 exceeds 0. Minus, plus and S of I equals Y. For I in range n minus 1 down to -1 non-inclusive, stepping by -1, R sub I equals R sub I plus 1 minus S of I equals n. I equals 0, return I at the end, while L sub I less than equal to R sub I. So yeah, I is less than or equal to N, and I plus equals 1. All right, try this out. 2, 0, and 4. Oh, 1, 6, and 0. That's not right. Oh, wait, hold on. This guy should strictly, the Y should be greater than the nose, right? Nope. 0? Oh. It's right and the left. Hold on, I don't think I did this right. Do a little debugging. Int ln or 1, 2, 2, and then 3, 0, 0, 1. Okay, so okay, that does look what I was trying to do. Let's check the logic here. Okay, so 0, 1, 2, 3, 4. The indices, there's 3 Ys. Oh, the penalties of the Ys you have to count from right to left then, right? And those from left to right. So I think I had this general idea I think is right. But the thought process is kind of backwards when I implemented it. So if you have Y, Y, and Y, it goes from right to left. One, 2, 3. So if we close the shop here, we'd have to pay for 3 Ys. Oh, actually, you know what? The Ys and the N. Okay, that should be fine. Okay, and then N's would be 0, 0, 1, right? 1. So this is the position where we would return because the Ys from the right is not strictly greater than the N's from the left. Right, so just call this guy R, R, right from right. Oops, hold on. Right to left for the Ys, left to right for the N's. It's not quite right. The N's, the Ys, the left and the right. So left will be the Ys, right will be the N's. Okay, and then our left is less than or equal to right. Okay, that looks good. Okay, so we see 2, 0, and 4. Uh-oh. 2, 0, 4 looks good. Okay. Oof. Hope it's 3, but I expect 4. It's 3, but I expect 4. Okay, let's see what we got here. Oops. And L and R. Oh, that right west one needs to be changed. If I is less than or equal, honestly, in otherwise 0 up to n plus 1. Oh, no way. 0, 1, 2, 3, 4 in there. Oh, okay. Less than or equal to, then we can continue till 4. Okay, make sure I didn't break the other stuff real quick. Do the regression, right? 204. Oh, that does break it. Ah, I need to go from right to left. Okay. I equals n 0 is less than equal to I minus equals 1. Oh, now I'm just confusing myself. I'm getting it totally wrong. So actually, now that we're going left to right, and we're going right to left, right? Totally confusing myself. Yeah, so I think the pre-processing looks okay. Just like my logic, I'm gotta go slow to go fast sometimes. So slow down. Take a look at this. This is y, n, y. Go from right to left. The answer is 1. Also, I is greater than or equal to r sub I. Let me move over. This is true. Okay. Make sure this corner case is still cool. No, it's not. Y and YY is not correct. Y and YY. We want to include that last Y. Strictly less than? No, 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 it doesn't work. It works for that case. And sub I is less than sub I. The current one, Yeah, it doesn't work. Huh. Yeah, I'm totally missing something here. For this case, right? We got these two guys. The amount of y's from right to left, amount of n's from left to right. We're better off here. Or if we should start this off as one then. That's a total hack. Yeah, it's a hack. Okay. Now I'm just throwing stuff up against the wall. I'm not really thinking too much. 32 minutes left. Mm. The shop is closed. It's +1 for each in past a pivot point. +1 for each in to the right if we close there. Non-inclusive of that though, right? Into the right, non-inclusive. And +1. Oh, maybe I should just calculate them then. What the penalty is. Find the minimum penalty. All right, let's just keep it super simple, right? Let's just remember, don't just try stuff out. Just keep it super simple. keep it super simple, right? Just add y's or accumulate, right? Pre-process the y's and n's, calculate penalty, return minimum, first minimum, then left. Okay, all right, so okay, so L and R are these guys. Equals this guy, R equals that guy. Left is the nose. So when you close at the ith, it's L minus 1. L minus 1. The rights are the y's. So if we close here, let's just do it for this first one. How about just to keep track of each penalty. Based on the example. Why? Okay, so this is left and right. Left is the nose, the accumulated nose. Okay, so what is the penalty here? If it closed here, it'd be 1, 2, 3. Right, it'd be 3 would be the penalty if it closed on the first. Right, that doesn't count. It's the number of y's minus the number of n's. Y minus n, so it's 2, 0, 0. If it closed here, the penalty would be 1, right? No. 2, 1, 2. 1, 2 there. 2, 3, 2, 1, 2, 1. 3, 2, 1, 2, 1. 3, 2, 1, 2, 1. But it's the left and the right, not inclusive. 3, 2, 1, 2, 1. How much time do we have left? 26 minutes. Just stick another 0 here just to make the calculation easier. Count. 1 is 1 plus 0. 2 is 1 plus 1. 1 is 1 plus 0. L sub I plus R sub I. I wonder if I should put another 0 here then. 3 there. R sub I plus L sub I. Doesn't count. The ends don't count, only the y's count. Y's count. N. Only the y's count, but the n does not count inclusive. N's to the left. Okay, and my kids came home and it's time to put on the blinders. Yeah. All the right y's inclusive. About the best. Okay. Those are right. I'm gonna get those backwards. Come on. What the heck? Come on. 204. Y. Looks good. Yay. Hello. Yeah. Well, that took a while. Longer than I expected. Oh well, at least I got it. 15 minutes left. Ay. 11:35. 35. This is about 34 minutes. Which was eventually, you see, like let's go back. Yeah, it's okay. Consider all the candidates and from the best from the left. Does that work? Index of best? I don't know if index of, no. Yeah, that works. It's a decent solution, right? See what this dude came up with. And all the y's. Subtract 1 + 1. Interesting. Holy cow, what junk. What junk. Junk. It sucks, man. Most of these top voted solutions are just junk. Like one legit dude surrounded by a bunch of not legit dudes. This dude's totally legit. All right, whatever. So frustrating to see so many junk solutions voted up. A few solutions, yeah. So basically prefix sums, right? For the no's from left to right and y's from right to left. Oops. Prefix sums of or counts, accumulated counts in from left to right and y from right to left. Then JavaScript, Python 3, Rust, C++. Okay. Recompute prefix sums as L and R correspondingly. Then each ith candidate is, I guess, ith penalty is R sub I plus L sub I minus 1. Turn the index of the It's not right. Count the ins to the left, ours to the right. Oh, right, minus left or plus left. Okay, that's good. Okay, account distant. I'm gonna yeah, do this later. Implement. Good enough. We compute the prefix sums for the human accounts of n from left to right and y from right to left. Correspondingly, then each index candidate penalty is r survive plus l survive minus 1. Return the index, the minimum ith index of the minimum candidate. That's okay.